Hello everyone and welcome to this channel. Today we're diving into a massive, honestly almost universal problem in the DevOps world. Why your simple Docker applications are loaded with so much unnecessary bloat and exactly how we can fix it. If you've ever built a container and wondered why the file size is absolutely massive for a tiny app, you are definitely in the right place.
I mean, really think about it. Why on earth does a basic calculator application, maybe just a few lines of Python or Go code, end up lugging around an entire Ubuntu operating system with it? It's completely wild when you step back and look at it. You just want to run a simple script, but suddenly your image size balloons to nearly a gigabyte. This massive file size slows down your deployments, it eats up expensive cloud storage, and as we'll see later, it creates some pretty huge security risks.
So here is our roadmap for this explainer. First, the bloat problem. 2, multi-stage builds. 3, Distroless images. 4, the Golang size reveal. And 5, the ultimate security advantage.
Okay, Section 1, the Docker bloat problem. Let's understand why these images get so massive. Typically, when you start containerizing an app, you follow a set of steps that looks exactly like this. You grab a heavy base image, like Ubuntu, which is maybe 400 megabytes right out of the gate. Then, you start installing your dependencies, compilers, package managers, libraries, the whole shebang. Finally, you build your application and run it. The problem is, you're stacking all of these dependencies on top of each other in the final image. It's literally like packing your entire house, the furniture, and the kitchen sink just to go on a weekend trip. You don't need the kitchen sink at the hotel, just like your app doesn't need a compiler in production.
Let's take a closer look at this unnecessary production baggage we're dragging along. To actually execute your final application, all you really need is the runtime environment. You know, like the Python runtime or the Java JRE, and your compiled code. Yet, traditional single-stage builds ship with all these heavy build tools. You're deploying apt package managers, source code files, and heavy compilers straight into your production environment. Not only is it heavy, but it's completely unnecessary for simply running the application.
Moving on to Section 2. Multi-stage builds explained. This is all about separating your build from your runtime.
And, well, this brilliantly illustrates the exact concept. Instead of one massive container, we break the process into stages. Stage 1, that's your heavy lifter. You use that big, rich Ubuntu image, you install your compilers, your heavy libraries, and you build your application binary. But here is the magic. In Stage 2, you start completely fresh with a brand new, super lightweight image. You then copy strictly the compiled binary from Stage 1 into this clean, empty Stage 2. All that heavy build baggage, it gets left behind and thrown completely away.
Now you might be sitting there wondering, wait, do I need to manage multiple Docker files to do this? Nope, absolutely not. You split your Docker file into 2 parts, using 2 from statements in a single file. You just create an alias for your first stage, like from Ubuntu as build, and then in your second stage, you simply say copy-from equals build. It cleverly drops the heavy base image right before outputting the final product. Your workflow stays exactly the same, but your output gets infinitely smaller.
Section 3. Enter Distroless images, stripping down the OS. So the crucial point here is understanding exactly what this is. A distroless image is basically the ultimate diet for your Stage 2 run environment. It's a highly minimalistic Docker image containing strictly what your application needs to run and absolutely nothing else. It is completely stripped of standard operating system features. If you have a Python app, a Python distroless image contains the Python runtime and literally nothing more.
Now, when developers first try Distroless, they usually experience what we call the no-shell shock. Because the OS features are completely stripped out, you're missing commands you're probably used to having. If you try to run an ls command to list files or use curl or wget inside this container, it's going to fail. There is no package manager. There isn't even a shell. But I assure you, while it might be a bit shocking to lose basic commands, this is actually a massive advantage for production, which we'll cover in just a moment.
All right, Section 4, the Golang size reveal. Let's put this theory to the test.
For an application written in a statically typed language like Go, we have a total secret weapon. Because statically typed applications don't even need a runtime environment to execute, unlike, say, Python or Java, we can use something called the Scratch image for our Stage 2. The Scratch image is essentially an empty container. It is the absolute most minimal, distroless image available in the entire Docker ecosystem.
Now, what's really interesting is this final size comparison.
On the left, if we build our Golang calculator using the traditional method, our final image weighs in at a massive 861 megabytes. But on the right, by combining a multi-stage build with an empty scratch image, our final size is just 1.83 megabytes. Just look at that contrast. No, really, look at it. That is a nearly 800 times reduction in file size. Just let that sink in for a second. We went from almost a gigabyte down to less than 2 megabytes, simply by combining those two simple techniques, multi-stage building and using a Distroless container. That means 800 times faster pull times, drastically faster deployments, and significantly reduced cloud storage costs. It's a real game changer.
Finally, Section 5, the ultimate security advantage. Let's see why smaller means safer.
Look at this security contrast. With a traditional image, your attack surface is, frankly, massive. Hackers look for vulnerabilities in standard operating system packages. But if you remember our no-shell shock from earlier, we stripped away tools like wget, curl, and even the shell itself in a Distroless image. So even if a bad actor somehow manages to get inside your container, they literally have zero tools to exploit it. They can't download malware, they can't browse your file system, because the commands to do so literally do not exist in the image. It makes your vulnerability threat near 99% free.
Adopting multi-stage builds and Distroless images shouldn't just be some neat optimization trick, it really should be the standard for all your future containers. It completely solves the massive file size problem, and it hardens your security overnight. So I leave you with this question. Is it finally time to drop the bloat and secure your deployments? In last safe for regular updates, subscribe to the channel, and if you like it, share the video.